we are going to look at the sum and difference identities. This is found in your book on page 599. It's also found on the yellow cardstock that I gave you in class. It is right across from the Pythagorean identities in class that I gave you from class. The book uses U and V. The sheet that I gave you uses alpha and beta, but they are the same formulas. The way you read this is a little confusing for some students. Notice that the top sign is a plus. Over here, the top sign is a plus. That means this formula is actually sine of u plus v equals sine u cosine v plus cosine u sine v. It's also sine u minus v equals sine u cosine v minus cosine u sine v. The one that's down here, erase this, the one that has cosine on it, has a plus on the top, which means that in the formula that goes with the addition actually has a subtraction in it. On the one that has the tangent with it, the formula has addition on the top, so the top part of the formula has addition for addition, but the bottom of the formula has subtraction in the addition formula. So basically, the top formula goes with the top sign, the bottom goes with the bottom of the formula. So be careful when you're doing these and make sure that you're following the correct sign, okay? So we're going to do a couple of practice problems so that you can see how to use these, and then we'll go from there. Now this is number 52 in your book in section 7.1. Let's see, it's on page 601 in your book, and it wants you to find cosine of 75 degrees exactly. Now, if you look at your unit circle that we have, and again, that's on that yellow sheet, cosine of 75 is not one of the exact identities that we have, but we can use some of the things that we have to make this work. If we look at our formulas and we notice that they are all sum or difference identities, we can write 75. We can write it a couple of different ways. We could write 75 as 45 plus 30. We could also write it as 120 minus 45. Both of those things are listed on our unit circle. We've got 45, we've got 30, we've got 120, we've got 45. All those things listed on our unit circle. I'm going to choose to write it as an addition. So I'm going to write cosine of 75 as cosine of 45 degrees plus 30 degrees. So I'm going to write it in as an addition. So I'm going to go over and I'm going to look at my chart, at my sum and difference formulas, and I'm trying to find cosine. So I'm going to look at one that says cosine beside it. I'm using addition, so I'm going to look at one that has cosine with addition on it. So I'm going to look at the top sign. So I'm going to be looking at this one on my chart. And that means that alpha is 45 and beta is 30. And I can look at my unit circle and I can find all those things. I can find cosine of 45, which is equal to square root of 2 over 2. I can find cosine of 30, which is equal to square root of 3 over 2. I can find sine of 45, which is equal to square root of 2 over 2. And I can find sine of 30 degrees, which is equal to 1/2. So those are all the things that I need for my formula. When I look at my sheet, the formula for cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Look at your sheet and you will see that formula. So I've gone to my unit circle, I've found all those values. Alpha, the way that I wrote it, I wrote 45 plus 30. So alpha is 45 degrees, beta is 30 degrees. And I just need to go to my sheet and fill those things in. So cosine of alpha is square root of 2 over 2. And since there's nothing between these two things, it denotes multiplication. So square root of 2 times square root of 3 over 2 minus square root of 2 over 2, because that's the sine of 45, and sine of 30 is 1/2. If you're bad with fractions, you may need to do a little review of multiplication and division of fractions and addition and subtraction of fractions. So over here we have multiplication. We don't have anything we can cross cancel, so we're going to have to multiply straight across. Remember, with radicals, as long as they're the same kind of radical, you can multiply the numbers and put them back under the radical. With fractions, we multiply straight across, so 2 times 2 is 4. This one we have square root of 2 times 1, which is square root of 2, and 2 times 2, which is 4. We have subtraction with fractions. They have the same denominator, so we don't have to find a common denominator. So our final answer is square root of 6 minus square root of 2 over 4. I cannot combine those because they don't have the exact same number underneath the radical. So this is my final exact answer. I could check this by punching square root of 6 minus square root of 2, enter, divided by 4, enter, on my calculator, and comparing that to the cosine of 75. They may be slightly off, but they'll be close to each other, close enough that you can be sure of whether or not you have the correct answer. So let's look at another couple of kinds of ways that we could use this. Let's go over and look at number 58 in our book. Now in this one, they want us to actually put this back together as one single function. So what I do is I look at my formula and I find a formula that has addition in it, and I look for one that has cosine, cosine, plus sine, sine. And when I look at my chart, I see that cosine of alpha minus beta matches up to that, because on my chart it says cosine of alpha, cosine of beta, plus, and that's what this one is, sine of alpha, sine of beta. Now the way this matches up, it means that 83 is alpha and 53 is beta. So when I look at these two things, if 83 is alpha and 53 is beta, what it's really showing me is cosine of 83 minus 53, and this is of course in degrees, and 83 minus 53 is 30. Now we do have an exact number for this on our unit circle, but for this section in the book, they're just wanting you to be able to put these identities back together. So they're looking for the approximate answer from your calculator, which is 0.8660. That's what they're looking for here. Not all of these answers that you get here will be things that you will find on your unit circle, because the idea here is to be able to work with the identities and put them back together. This last one I want us to look at is number 66 in your book. It tells us that sine of u is 3/5 and sine of v is 4/5. Now remember, the chart that I gave you uses alpha and beta. The book uses u and v, and you use those interchangeably. So it's really saying that sine of alpha is 3/5 and sine of beta is 4/5. It also tells you that it's in the first quadrant, because it says it's between 0 and pi over 2. And we know we have that beautiful butterfly that we can get our trig identities from. It's either going to be one of those 4 angles. Since this one is the first quadrant, it's this one. So when we draw this out and we look at it, if u, and you can put u in whichever corner you want to, if its sine is 3/5, side opposite would be here, and hypotenuse would be here. These are all going to be positive because it's in the first quadrant. Pay attention to that though. If this one is u, then this one has to be v. So sine of V is 4/5, so side opposite is 4, and hypotenuse again is 5. So that's going to tell us all the measurements that we need. It's actually asking us in number 66 to find the tangent, I believe. Let me go back and look at the directions. It's actually asking us to find tangent of U minus V. So in this one, we have tangent of U minus V. And remember in our book, or with our chart, it's really saying alpha minus beta. So when we look at our formula for tangent of alpha minus beta, we have our formula that I've pulled off of our sheet. If we know that we have our triangle that is labeled appropriately, and this is alpha and this is beta, then we can pull tangent of alpha and tangent of beta from that triangle as well. So tangent of alpha would be side opposite over adjacent, so it would be 3/4. Tangent of beta, opposite over adjacent, would be 4/3. And I just need to simply put this in my formula. So tangent of alpha is 3/4 minus tangent of beta is 4/3 over 1 plus tangent of alpha, 3/4, times tangent of beta, 4/3. And we're going to need to do some math here. You're going to need a common denominator for the top. If you're bad at fractions, do this on your calculator, but the common denominator is 12. 4 into 12 goes 3 times, and 3 times 3 is 9. 3 into 12 goes 4 times, and 4 times 4 is 16. So on the top, we have 9 minus 16 is minus 7 over 12. On the bottom, we have 1 plus 3/4 times 4/3. Well, 3/4 times 4/3, the 4's and the 3's cancel. So on the bottom, we actually have 1 plus 1, which is 2. So we have this problem now. Negative 7/12 divided by 2 over 1. So negative 7/12 times 1/2 is negative 7 over 24. And that is our final answer. I'm going to make a homework assignment so that you can practice these. When we do finally come back to class, hopefully we'll be able to go over some of these things.